On the morning of July 19, 1943, a captured American M4 Sherman tank rolled off a transport ship at the Yokosuka Naval Arsenal, 50 kilometers south of Tokyo. Japanese Army engineers gathered around the vehicle with notebooks and measuring tools. They had been promised American armor for months. Now they would finally understand what they were fighting. The lead engineer, a man named Tomio Hara, walked slowly around the Sherman. He had designed components for Japan's Type 97 Chi-Ha medium tank. He knew armor. He knew engines. He knew what a combat vehicle required to function in the tropical hell of the Pacific Islands. This American tank, he had been told, was inferior, crude, hastily built by a nation that understood cars but not war machines. Hara placed his hand on the Sherman's hull. The steel was thicker than he expected. He knocked on it with his knuckle. The sound was solid, uniform. He looked at his colleagues and said nothing, but a question had already formed in his mind. What if everything they had been told about American industrial capacity was wrong? The story of how Japanese engineers came to test the Sherman and what they discovered when they did reveals one of the war's most consequential intelligence failures. Japan had entered the Pacific War believing that American tanks were vulnerable, that American industry was incapable of mass-producing quality armor, and that Japanese anti-tank weapons would prove sufficient against anything the Americans could field. The engineers at Yokosuka were about to learn otherwise. Understanding this story requires understanding what Japan believed about American armor in 1941. Japanese military intelligence had compiled extensive reports on American tank development throughout the late 1930s. The assessments were remarkably consistent. American tanks were designed for a war that would never happen. They were too heavy for Pacific Island terrain. They required too much fuel for extended operations far from supply bases. They were built by automobile manufacturers who knew nothing about armored warfare. The Japanese Army's own tank doctrine reinforced these conclusions. Japan had developed light, mobile tanks optimized for infantry support in China. The Type 95 Hago light tank weighed less than 8 tons and could navigate terrain that would bog down heavier vehicles. The Type 97 Chi-Ha medium tank, at 15 tons, was considered adequate for any opponent Japan might face in Asia. Japanese planners believed that speed and maneuverability mattered more than armor thickness or gun caliber. This doctrine was not born from ignorance. It reflected hard-won experience fighting in China, where roads were primitive and bridges could not support heavy vehicles. Japanese engineers had designed tanks that could operate in this environment. Light weight meant fewer mechanical breakdowns. Simple construction meant easier field repairs. Modest fuel consumption meant longer operational range with limited logistics. The problem was that this doctrine was built for fighting Chinese forces who possessed almost no modern armor. Japanese tanks had rarely faced opponents with equivalent or superior equipment. When they did encounter Soviet armor during border clashes at Khalkhin Gol in 1939, the results had been sobering. Soviet BT-7 tanks had outgunned and outmaneuvered Japanese armor with ease. But Japanese military leadership had classified those battles as inconclusive, and the lessons learned were not widely disseminated. Colonel Iwakura Hideo Fieki, who served in the Army Ministry's Military Affairs Bureau, later wrote that Japan's tank program suffered from what he called victory disease. The easy conquests in China had convinced planners that Japanese equipment was adequate. The idea that American industry might produce armor superior to anything Japan fielded seemed absurd. America built tractors and automobiles. They did not understand war. If you're finding this deep dive into Pacific War armor development as fascinating as we hoped, consider subscribing to our channel. We uncover these precise technical stories that reveal how wars were really fought and really lost. Japanese intelligence officers monitoring American tank production in 1941 noted the M3 Lee medium tank entering service. Reports described it as awkward, with its sponson-mounted 75mm gun and limited traverse. The design seemed to confirm Japanese prejudices. The Americans were improvising. They were mounting guns in unusual configurations because they lacked the engineering sophistication to design proper turret systems. What Japanese analysts failed to understand was that the M3 Lee was a stopgap measure. American tank designers knew the vehicle was flawed. They were already working on a replacement that would mount the 75mm gun in a fully rotating turret. That replacement, the M4 Sherman, entered production in February 1942, just 2 months after Pearl Harbor. The Sherman represented everything Japanese intelligence had said was impossible. It weighed 30 tons, triple the weight of Japan's Chi-Ha. It mounted a gun powerful enough to destroy any tank in the Japanese inventory. It incorporated welded armor construction that was stronger and faster to produce than riveted designs. Most importantly, it was being built in quantities that Japanese planners dismissed as propaganda. American production figures for the Sherman seemed fantastic to Japanese analysts. Ford's River Rouge plant in Detroit was converting automobile assembly lines to tank production. Chrysler was building an entirely new facility, the Detroit Tank Arsenal, dedicated solely to Sherman production. The Fisher Tank Arsenal in Grand Blanc, Michigan, was constructing Shermans using techniques borrowed from railroad car manufacturing. The numbers being reported suggested the Americans would build thousands of medium tanks per month. Japanese industrialists who reviewed these reports found them impossible to believe. Japan's entire tank production capacity in 1942 amounted to roughly 1,200 armored vehicles of all types. The idea that America could produce more tanks in a single month than Japan produced in a year seemed like obvious exaggeration designed to intimidate. Hara, the engineer examining the Sherman at Yokosuka, had read these intelligence assessments. He had believed them, or at least had wanted to believe them. Now he was looking at physical evidence that contradicted everything he thought he knew. The Sherman was real, it was here, and it was nothing like what he had expected. The tank had been captured on Guadalcanal during fierce fighting around Henderson Field. American Marines had abandoned it after mechanical failure during a night engagement in late 1942. Japanese infantry, expecting to find a burning wreck, discovered instead a disabled but largely intact vehicle. The engine had seized, but the armor was undamaged. The gun was functional. The internal systems were accessible. Getting the Sherman back to Japan had required extraordinary effort. Japanese engineers on Guadalcanal had jury-rigged repairs sufficient to get the tank moving again. They had loaded it aboard a fast transport during one of the Tokyo Express nighttime supply runs that attempted to sustain Japanese forces on the island. The transport had made it back to Rabaul, where the tank was transferred to a larger vessel for shipment to Japan. The journey had taken months. The Sherman sat in storage at Rabaul for weeks while Japanese shipping tried to maintain supply lines under constant American air attack. When space finally became available on a transport heading back to the home islands, the tank was given priority over ammunition and food. Japanese Army leadership wanted to understand what they were fighting against. At Yokosuka, Hara and his team began their examinations systematically. They measured the armor thickness at multiple points. The frontal hull armor was 51 millimeters thick, sloped at 56 degrees from vertical. The effective thickness against a perpendicular hit was considerably greater due to the angle. Japanese anti-tank guns, even the Type 1 47mm weapon considered the Army's best, would struggle to penetrate at combat ranges. The turret armor was even more impressive. The gun mantlet was over 75 millimeters thick in places. The turret ring, a notorious weak point in many tank designs, was protected by overlapping armor plates that made it nearly impossible to disable with a single shot. Hara made notes in precise technical language, but his handwriting grew less steady as the measurements accumulated. The team moved to the suspension system. The Sherman used a vertical volute suspension that seemed crude compared to Japanese designs, but it was astonishingly robust. Each bogie assembly could be removed and replaced as a complete unit without specialized tools. A maintenance crew could swap out a damaged suspension unit in under an hour. Japanese tanks required careful adjustment and alignment of individual springs and shock absorbers, work that took trained mechanics several hours, even under ideal conditions. Hara examined the tracks. They were wide, distributing the tank's weight over a large surface area. Ground pressure was lower than the Japanese Chi-Ha, despite the Sherman weighing twice as much. This meant better performance on soft ground, less likelihood of getting stuck in mud or sand. The track pins were designed to be driven out with a sledgehammer and replaced without removing the entire track assembly. Simple, maintainable, effective. The engine drew particular attention. The Sherman at Yokosuka was powered by a Continental R975 radial aircraft engine producing 400 horsepower. Japanese engineers knew radial engines. They were complex, expensive, and difficult to manufacture. The fact that America was installing them in tanks suggested either desperate improvisation or terrifying industrial depth. Hara's colleague, an engine specialist named Suzuki, spent 3 days examining the Continental. He checked the machining tolerances on the cylinders. He inspected the crankshaft bearings. He tested the magnetos. Everything was built to aircraft standards. The Americans were putting aviation-grade engines into ground vehicles, not because they had to, but because they could afford to. The implications were staggering. Japan had fewer than 10,000 radial engines suitable for aircraft. The idea of installing them in tanks would have been unthinkable. Yet here was physical evidence that America was doing exactly that, and doing it with enough abundance to equip thousands of armored vehicles. Suzuki wrote in his report that the engine showed signs of hard use but no fundamental wear. The maintenance record, found inside the crew compartment, indicated the tank had operated for over 400 hours since its last major overhaul. Japanese tank engines typically required significant maintenance every 100 hours. The reliability differential was profound. The gun system revealed even more troubling details. The 75mm M3 gun was a remarkable weapon. It could fire both armor-piercing and high-explosive rounds, making it effective against tanks and infantry positions alike. The gun used a vertical block breech that was faster to operate than the horizontal mechanisms in Japanese tank guns. Rate of fire was nearly double what a Chi-Ha could achieve. But it was the gun sight that truly shocked the Japanese engineers. American tank designers had installed a telescopic sight with magnification and a reticle calibrated for different ranges. Japanese tank sights were simple iron devices with minimal magnification. American gunners could engage targets accurately at ranges where Japanese gunners could barely identify whether they were looking at a tank or a truck. The fire control system included a gyro stabilizer that kept the gun roughly on target even while the tank was moving. This technology was supposed to be experimental, something that worked in laboratories but not in combat vehicles. Yet here it was installed as standard equipment in a production tank. The Americans were deploying experimental technology as baseline capability. Hara spent an entire afternoon inside the Sherman's crew compartment. 5 men could operate this vehicle comfortably. The driver and assistant driver sat in the hull. The gunner, loader, and commander occupied the turret. Each position had adequate space to perform their duties without interfering with others. Visibility was excellent from all positions, with multiple periscopes and vision blocks. Japanese tanks cramped 3 or 4 men into spaces so tight that crew members could barely move. The Chi-Ha commander had to operate the radio, direct the driver, and command the gunner simultaneously because there was no room for additional crew. Combat efficiency suffered accordingly, but Japanese designers had accepted this as a necessary trade-off for keeping vehicle weight low. The American designers had made different choices. They had prioritized crew efficiency over weight savings. The result was a tank that could sustain combat operations longer because the crew was not exhausted from physical contortions inside a cramped hull. It was a philosophy that reflected industrial abundance. America could afford the extra steel required for a spacious crew compartment. Japan could not. The ammunition storage revealed another layer of American thinking that unsettled the Japanese engineers. The Sherman carried 90 rounds of 75mm ammunition distributed in racks throughout the hull and turret. Each round was stored in a protective sleeve designed to prevent sympathetic detonation if one shell was hit. The racks were positioned to maintain the tank's center of gravity even as ammunition was expended. Japanese tanks typically carried fewer than 60 rounds with minimal protection. A single penetrating hit that struck ammunition could turn the entire vehicle into a fireball. American designers had engineered around this vulnerability with careful placement and protective measures. It was the kind of detail that reflected thousands of hours of testing and refinement, the kind of development work that required time and resources Japan did not possess. The radio system was perhaps the most demoralizing discovery. Every Sherman came equipped with an SCR-508 radio capable of voice communication between tanks and with supporting infantry. The radio was reliable, weatherproof, and simple enough that crew members with minimal training could operate it. Japanese tanks in 1943 were still using flag signals for inter-vehicle communication. Only company commanders had radios, and those were temperamental devices that frequently failed in tropical conditions. Hara understood what this meant tactically. American tank platoons could coordinate maneuvers in real time. They could call for artillery support. They could report enemy positions to aircraft overhead. They were operating as part of an integrated system while Japanese tanks fought in isolation. The technical gap was not just about armor and guns, it was about battlefield coordination enabled by industrial capacity to mass-produce sophisticated electronics. The testing program expanded beyond static examination. Japanese engineers wanted to fire the Sherman's gun, test its mobility, and understand how it performed under stress. They transported the tank to a proving ground north of Tokyo where space existed for live fire exercises. What they learned during those tests demolished whatever remained of their preconceptions. The Sherman's 75mm gun was test-fired against a captured Japanese Chiha positioned at various ranges. At 1,000 meters, the American armor-piercing round punched through the Chiha's frontal armor and exited through the rear, leaving a hole large enough to put a fist through. The Japanese tank's armor was 47mm at its thickest point. It might as well have been paper. Engineers then positioned the Sherman as a target and fired Japanese anti-tank weapons at it. The Type 94 37mm anti-tank gun, standard infantry support weapon, could not penetrate the Sherman's frontal armor at any practical combat range. Rounds deflected off the sloped hull or shattered against the armor without penetrating. Only hits at extremely close range against the thinner side armor achieved penetration. The Type 147mm anti-tank gun performed better, but not well enough. It could penetrate the Sherman's hull armor at ranges under 500 meters if it struck a flat surface perpendicular to the projectile path. But the Sherman's sloped armor meant that most hits at combat angles deflected rather than penetrated. Japanese anti-tank gunners would need to achieve near-perfect shot placement to disable American armor. Hara wrote in his report that existing Japanese anti-tank doctrine was inadequate. Infantry tactics assumed that light anti-tank guns could stop enemy armor at typical engagement ranges of 600 to 800 meters. Against the Sherman, those tactics would fail. Infantry would need to let American tanks close to suicidal ranges before weapons could be effective. The casualties would be catastrophic. The mobility trials were equally discouraging. The Sherman was driven across terrain that would have immobilized a Chiha. Sand, mud, steep slopes, obstacles that should have stopped a 30-ton vehicle were negotiated with relative ease. The wide tracks distributed weight effectively. The powerful engine provided ample torque. The transmission, a 5-speed manual synchronized gearbox, allowed the driver to select appropriate gearing for different terrain. Japanese observers noted that the Sherman could climb slopes that their own tanks could not attempt. It could ford streams too deep for lighter vehicles. It could operate in mud that would bog down a Chiha within meters. The assumption that heavy American tanks would be confined to roads proved wrong. The Sherman was more mobile across country than Japanese armor, despite weighing twice as much. Fuel consumption data was meticulously recorded. The Sherman burned approximately 160 liters of gasoline per 100 kilometers of road travel. This seemed profligate to Japanese engineers accustomed to the Chiha's consumption of roughly 80 liters per 100 kilometers. But when they calculated operational range, the numbers told a different story. The Sherman carried 620 liters of fuel in protected internal tanks. Operational range exceeded 200 kilometers between refueling. More importantly, American logistics could support this fuel consumption. Japanese intelligence reports indicated that American tanker ships were delivering fuel to Pacific Islands in quantities that seemed impossible. Storage tanks were being erected at forward bases capable of holding millions of liters. The fuel consumption that seemed wasteful to Japanese planners was irrelevant to an opponent with effectively unlimited petroleum supplies. The final evaluation report compiled by Hara's team ran to over 300 pages. It included detailed technical drawings, metallurgical analysis of armor samples, performance test data, and tactical assessments. The conclusions were delivered in careful, bureaucratic language, but the implications were clear. Japan was fighting an opponent whose industrial capacity exceeded anything Japanese planners had anticipated. The report made specific recommendations. Japanese tank designs needed immediate revision to incorporate thicker armor and more powerful guns. Anti-tank weapons required urgent upgrading. Infantry tactics against armor needed complete restructuring. Perhaps most importantly, the report recommended that Japanese military leadership reassess fundamental assumptions about American industrial capabilities. The recommendations were ignored. Army leadership read the report and dismissed most of its conclusions. The engineers, they said, had been impressed by a single example of American equipment. One tank did not represent an entire industrial system. The Sherman might be well built, but American factories could not possibly produce them in the quantities being claimed. The intelligence assessments that had shaped Japanese planning for years could not be wrong. Some officers argued that the Sherman was a specially prepared example, built to higher standards than typical production vehicles to impress anyone who captured one. Others suggested that American industrial quality was inconsistent, that for every well-built Sherman, there were dozens of poorly assembled vehicles that broke down or failed in combat. These explanations allowed leadership to avoid confronting uncomfortable truths. Colonel Takeo Yasuda, an armor officer who reviewed the Yokosuka findings, wrote years later that the report was received with what he called polite skepticism. Senior officers thanked the engineers for their work, but made clear that strategic decisions would not change based on technical evaluations. The war effort would continue according to existing plans. New tank designs would be developed when resources permitted, but no urgent action was required. This institutional resistance to evidence reflected broader problems in Japanese military culture. Bad news was unwelcome. Reports that contradicted established doctrine were treated as defeatist. Officers who raised concerns about equipment inferiority risked their careers. The organizational incentives all pointed toward telling superiors what they wanted to hear rather than what they needed to know. Meanwhile, American Sherman production accelerated. In 1943, American factories built over 21,000 medium tanks, most of them Shermans. By 1944, monthly production exceeded 2,000 units. The numbers Japanese intelligence had dismissed as propaganda were actually conservative estimates. American industrial capacity was greater than even the Americans themselves had initially projected. Japanese tank production could not keep pace. In 1943, Japanese factories built approximately 600 tanks of all types. Chronic shortages of steel, machine tools, and skilled labor limited output. New designs like the Type 3 Chi-Nu medium tank, developed partly in response to the Yokosuka report, entered production too late and in numbers too small to matter. By the time Chi-Nu tanks reached combat units in 1945, the war was already lost. The engineers at Yokosuka had provided Japanese military leadership with accurate intelligence about American capabilities in mid-1943. Had their recommendations been implemented immediately, Japan might have developed more effective anti-tank weapons or revised tactical doctrine to account for American armor superiority. The war's outcome would not have changed, but Japanese defensive operations might have been more effective. Instead, the information was filed away and forgotten. Japanese infantry continued to face American armor with weapons inadequate to the task. Soldiers armed with magnetic mines and satchel charges attempted suicide attacks against Shermans because their anti-tank guns could not penetrate American armor at survivable ranges. The casualties were exactly as catastrophic as Hara had predicted. At Iwo Jima in February 1945, Japanese defenders faced an American assault supported by hundreds of Sherman tanks. Japanese anti-tank guns, positioned in carefully prepared defensive positions, engaged the American armor at close range. Many guns scored direct hits. Most of those hits failed to penetrate. American tanks absorbed punishment that would have destroyed any Japanese armored vehicle and continued advancing.
Lieutenant Toshihiko Ono, commanding a Type 1 47mm anti-tank gun on Iwo Jima, recorded in his diary that his crew achieved 3 direct hits on a Sherman at ranges under 300 meters. All 3 rounds deflected without visible damage to the American tank. The Sherman returned fire with high explosive shells that obliterated Ono's gun position. He survived only because he had been repositioning when the American counterfire arrived. Similar scenes played out across the Pacific. At Peleliu, on Okinawa, in the Philippines, Japanese soldiers discovered that their weapons could not stop American armor. The technological gap that Yokosuka engineers had documented in 1943 became a tactical reality that killed thousands of Japanese soldiers who were sent into battle with inadequate equipment. The human cost of ignoring the Yokosuka report is impossible to calculate precisely, but some estimates exist. Japanese Army records indicate that anti-tank units on Okinawa suffered casualty rates exceeding 80%. Most of those casualties occurred during engagements where Japanese weapons failed to disable American tanks. Soldiers died attempting close-range attacks because their guns could not engage effectively at distance. Around the 20-minute mark of learning this history, it's worth pausing to consider the broader implications. The Japanese leadership's refusal to accept evidence about American industrial capacity was not unique to them. Similar failures happened in German high command, in Italian strategic planning, in every Axis power that underestimated Allied production. The tendency to dismiss uncomfortable intelligence appears to be a common failure mode in military organizations under stress. After the war, Tomio Hara was interviewed by American technical intelligence officers seeking to understand Japanese tank development. He was asked why his Yokosuka report had not led to changes in Japanese equipment or doctrine. Hara's answer was simple. The leadership did not want to believe it. They had committed to a war plan based on assumptions about American weakness. Changing those assumptions would have required admitting that the entire strategy was flawed. Admitting strategic error was impossible for officers who had staked their careers and their nation's future on those plans. So they rejected the evidence, found reasons to explain it away, and continued with policies that were doomed to fail. Hara said he understood this impulse even as he recognized its futility. Telling the truth when the truth is unwelcome has never been easy, in any military, in any era. The Sherman tank tested at Yokosuka was eventually destroyed during an American bombing raid on the Tokyo area in 1945. The testing facility was hit by incendiaries, and the captured American tank burned along with the buildings that housed it. Hara survived the war and worked in Japan's post-war automotive industry, applying some of the manufacturing lessons he had learned studying American equipment. In the 1960s, Hara was contacted by a researcher compiling a history of Japanese wartime tank development. He provided copies of the Yokosuka report and discussed the testing program in detail. The researcher asked whether Hara felt vindicated that his warnings had proven accurate. Hara said vindication meant nothing. His job had been to evaluate American equipment and report his findings. He had done that job. What others chose to do with the information was beyond his control. The broader lesson from Yokosuka extends beyond tank specifications and armor thickness. It is a lesson about institutional failure, about the difficulty of accepting information that contradicts established beliefs, about the human tendency to reject evidence that demands uncomfortable changes. The Japanese engineers who tested the Sherman performed excellent technical work. The system that ignored their findings failed catastrophically. Modern militaries still struggle with this problem. Intelligence that contradicts prevailing assumptions is often dismissed or minimized. Equipment evaluations that reveal deficiencies are sometimes suppressed to protect procurement programs. The organizational dynamics that caused Japanese leadership to ignore the Yokosuka report still exist in different forms today. Humans have not changed. The challenge of accepting unwelcome truth remains as difficult now as it was in 1943.
The Sherman tank that Japanese engineers examined represented more than American industrial capacity. It represented a different philosophy of warfare, one that prioritized sustainability over elegance, abundance over perfection, crew survivability over vehicle weight. Japanese tank designers had optimized for different constraints and achieved impressive results within those limits. But when those designs encountered an opponent with fundamentally different resources, the limitations became fatal. Japan entered the Pacific War believing that spirit would triumph over material, that superior training and fighting spirit would overcome American industrial advantages. The Yokosuka report provided concrete evidence that this belief was wrong. American tanks were not just more numerous, they were better designed, better built, and better supported than anything Japan could produce. The evidence was irrefutable. The decision to ignore it was a choice. That choice cost lives. Japanese soldiers who might have been equipped with effective anti-tank weapons went into battle with inadequate guns. Infantry who might have been trained in revised tactics faced American armor using methods that did not work. The failure was not technical. Japanese engineers understood the problem and proposed solutions. The failure was institutional, a refusal by leadership to confront reality when reality contradicted their plans. Thank you for watching this deep exploration of a moment when truth confronted belief, and belief won, at least temporarily. If you found this examination of wartime intelligence failure as thought-provoking as we hoped, please consider liking this video and subscribing to our channel. We bring you these detailed technical histories because they reveal how wars are actually fought and actually lost. The story you just heard is not just about tanks and armor penetration. It is about the eternal human struggle to see the world as it is rather than as we wish it to be. That struggle continues today, in different forms, with different stakes, but the same fundamental challenge. Share your thoughts in the comments below and let us know what other stories from the Pacific War you would like us to explore.